This is your Daily 10. Non-calculator, video 13. Make sure you pause the video and attempt each question before you watch the solution. So here's your first question. Here what we need to do is change some numbers, some of which are in standard form, some of which use scientific notation, and some are just normal numbers, to try and work out which one's the biggest. So if you remember, 6.15 times 10 to the power 4, well that simply means we need to multiply 6.15 by 10 4 times. So in order to do that, we would times by 10 again, and keep times by 10, so 4 times to give us this. This one is already completed. 6.2 times 10 to the power 3, so we times 6.2 by 10 again, and by 10 again, so 3 times to give us this. And 61.6, just be careful, timesing this by 10 3 times, we'll times by 10 again, and by 10 again would give us this. So we just need to work out which is the biggest. Well, 61,600 is biggest, so we'd circle the end number. Here's your next question. So the first thing we need to remember about circles is that they are always in the form x squared plus y squared equals the radius squared. So whatever the radius of this circle is, when we square it, it will equal 1/4. So we've got that r squared, the radius squared, equals 1/4. So what we need to look at and work out is the square root of 1/4. Now if you're not sure and you're not happy about doing square roots of quarters, there's a quick way of doing it because we are given 4 options. We just need to look and think which of these numbers times by itself would equal 1/4. Well, the one that jumps out is 1/2, because if I were to do 1/2 multiplied by 1/2, remember timesing fractions just means times the top and times the bottom gives us 1/4, so the radius must be 1/2. Here's your next question. Here what we need to do is try and change a recurring decimal into a fraction. Now there's a couple of methods of doing this. The one that I tend to work with is if we say and let x equal whatever decimal we are given. So in this case 0.15 recurring. Now I'm just going to put that number a couple of times. Now because there is only one number repeating in this decimal, what I'm actually going to do, it's a little trick that we've got that works, is I'm going to times that number by 10. If there'd been 2 numbers repeating, I'd have done 100, 3 numbers repeating, 1,000 and so on. Well, if I times this number here by 10, I'm just moving all of these numbers along one place above the decimal point, so that gives us 1.555. Just going to write the same number, my x, just underneath. And what we then do is a little column subtraction. So it's useful when you're writing these numbers down to make sure you're lining everything up to keep everything nice and neat. 5 take away 5 is nothing, same again. 5 take away 1 is 4. 1 take away nothing is 1. Don't forget your decimal point. And then 10x take away x is 9x. Well, this tells us that 9 lots of something equals 1.4. So effectively I'm now just solving an equation. So I'd need to divide by 9. Don't forget non-calculator paper. So the cheat way of dividing by 9 is simply to put over 9. So this is the value of x. This is the fraction that we were looking for. However, we don't want a decimal inside a fraction. So what we have to do at this point is get rid of that decimal. To do that, best way, if we times the top by 10, it would give us 14. We'd have to do the same to the bottom. to give us 90. Now the question did say it wanted this in its simplest form, so simplifying this, it would give me 7 over 45. And there is my solution to this question. Here's your next question. Now this is trying to test your knowledge not only of expanding double brackets, but then also to try and do a little bit of a problem solve. Because it's got double brackets, the first thing I'm going to do, as always when I see brackets, is expand them. So 3x times x is 3x squared. 3x times that minus 2 will give me minus 6x. I then need to do 1 times x, that's just x, and then 1 times minus 2, so positive times a negative, minus 2. If we then add these bits on at the end, just after the brackets, plus ax and plus b, we get something that looks like this. Now I'm just going to neaten this little bit up here, minus 6x plus x, and actually going to rewrite this as 3x squared minus 5x, because minus 6 plus 1 gives us minus 5. I'm going to bring this ax over here, so I'm just reorganising it to get the x bits together. We've then got minus 2 plus b. So all I've done here is group together the x squareds, the things with x, the terms with x, and the terms that are just on their own. Now what we want is for this to be exactly equal to this here. So we want it to be exactly equal to 3x squared plus 8x minus 5. So all we need to do now is find the values of a and b to make this line here exactly the same as this line here. So if you notice, 3x squared, these two are the same. We've got minus 5, lots of x, plus a, some lots of x, and we need to have 8x altogether. So what value do you need to do? Minus 5 plus something gets us up to 8. Well, that a, therefore, must be 13. So I can put that on the answer line. We've then got minus 2 plus something would get us to minus 5. Well, to get from minus 2 to minus 5, we would have to take away 3. So b must be minus 3. And there are our two solutions for a and b. The final question in this video is this. So it's a very good idea for you to know the graphs of y equals sin x, y equals cos x, and y equals tan x, because they have done in the past questions where they'll just ask you to draw them. So what you need to know about tan x is two key points. What you've got at the value of 90 and the value of 270 are two lines called asymptotes. Now these are lines that the graph does not touch, but it does get very close to. So tan x starts at 0, 0, curves up, getting very close to this asymptote, but never actually touching. It then starts again down at the bottom, very close, but not touching the asymptote, and curves up, crossing at 180. It then repeats this exact same curve here. Again, not touching the asymptote, but getting very close. And then again, we've got a repeat, and the tan graph just continues to repeat this if we went further than 360 to give us something that looks like that.